Today we are going to work with some different computation strategies for the addition problem of 342 added to 179 in hopes of steering away from the typical unfriendly standard algorithm. This gives all students a few more friendly options when solving addition problems. First of all, it is recommended to estimate computations such as this one because this estimate can serve as a very strong guide for when you do begin the actual computation. By that I mean an estimate can put you in the right ballpark and can serve as a strong check when you do actually solve the problem. If the estimate and the answer are close, you likely nailed it. If not, you might want to check back and recompute. When estimating, remember that it doesn't need to be specific. Estimate with whatever you feel comfortable with because it's just to get you in the right ballpark. So we could even round to the nearest 100 with this one. 342 rounds down to 300. And 179 rounds up to 200. That gives us an easy estimate of 500, which is a fine estimate. It's comfortable and it sets you up pretty well for when you do the problem. If you want to be more specific, you could do multiples of 50. So 342, you could go to 350, and 179, you could once again go to 200, which would bring you to 550. Once again, a fairly good estimate. Lastly, if you're feeling really confident, you could round to the nearest 10. So in this one, 342 would round to 340, and 179 to 180, which gives you 520, which is a very good estimate, but all of them are good estimates. They don't need to be the exact answer. But when you get your final solution, your answer should probably be in that ballpark. Okay, so moving on to now solving the equation. We might want to solve it concretely using base 10 blocks for the visual learners like myself. This can be very, very valuable. So if we look here at our equation, we have 300 blocks to give us our 300. We have 4 10s for the 40, and we have our 2 1s. We made them a little bigger just so we can see them for the 342 total. And on the other side, we have our 100 block, we have our 7 10s, and we have our 9 1s to make the 179. So just looking at that right away, if we want to get away from our standard algorithm, we have a lot of options, but the one that sticks out in my mind right away would be sharing. Just because I look over here and I see these 9 1s, and that's really bothering me because so easily we can make that into a 10. So how could we make that into a 10? Right away, if we want to share, we bring one of these over, just like that. We get 10 1s. That gives us a 10. Just with the sharing, you bring that over to the other side, you got to subtract it from the other side. So we now have 10 1s, which turns into a 10, just like that. And just like that, we have 180 now, which is a lot simpler number to work with. But remember, we shared from the left side, so we got to subtract that 1. So we now have 1 less, which is 341. So just looking at that now, that's already a lot better, but I know we could probably make this equation even more student friendly. So if we wanted to make this even more student friendly, what could we do next? To continue with that sharing, we now have 8 10s, which is really good, but I see that we have a few more 10s still on the other side here, which we could definitely share over. And that would be pretty nice to get to a number like 200. So what if we took 2 10s, we shared them over here, and just like that we now have 10 10s over here, which, if you know, 10 10s turns this into a 100 block. And just like that, we're no longer 180. We're a great number to work with, like 200. But remember, we shared from this side, so what we subtracted, we now got to subtract from this side. We took 2 10s to share over here. We're not 341 anymore. We're 321. And now, if you look at that, we have a pretty nice equation to work with. 321 added to 200, we get our grand total. We get 521. Okay, so really quickly, let's go through the sharing strategy pictorially and symbolically at the same time for this addition equation. So first of all, we have our 9 1s. If we share the 1 over, it gives us a 10. So we add that 10, we make sure we cancel this one out. We now have 180, and we now have 341. To make that even more simpler, let's share 2 more 10s. Bring these 2 10s over. We now have 10 10s, which cancel out to give us another 100. But we cancel these out, we now have 321, and we have 200. So we count that up, now we add these together, we have 100, 200, 300, 400, 500, and 2 tens is 20, and 1. 521 is our answer. Okay, so no worries if the sharing strategy didn't work that well for you, because there are plenty of other addition computation strategies that work a lot better and are a lot easier math-wise than the standard algorithm. So this one that I want to try now with you is splitting. So splitting essentially works to make the numbers easier to work with based on their place value. So you want to work with each place value. You start with your 300 and your 100. Add those together. Keep it simple. You get a nice number like 400. Then you work with your tens. You got a 4, so that's a 40, right? So we add 40 to that. We get 440. Now the other side, we have a 7. That's for 70. That's in the 10 spot. Add those together. You get 510. What's left are the 1s, a 9 and a 2. Quick math, add 9 and 2 together, we get 11. We add 11 to the 510, we get our answer of 521.